Okay, welcome to Factoring Day 2. We're going to continue to factor polynomials, but tonight we're going to take a look at factoring out the GCF first, and then factor by grouping. So let's go ahead and get started. Okay, so we are going to look at more factoring practice, and first we're going to take a look at see if the quadratic has a GCF, or a greatest common factor. So we want to look at the coefficient of each of the terms and see if there's a common factor between 4, 2, and 30. And there is. The common factor of 4, 2, and 30 is 2. And we also want to look at the variable and see if it has a common factor. And these two have a common factor of x, but this one doesn't have an x. So our GCF, for this example, our GCF is 2. So we are going to factor out a 2. So our greatest common factor is 2. So we're going to divide each term by 2. And when we do that, we get 2 times 4x squared divided by 2 is 2x squared. 2x divided by 2 is x, and 30 divided by 2 is 15. Now we're just going to follow the rules of factoring where the leading coefficient is bigger than 1, and we're just going to be looking at factoring this part because we've already factored out the GCF. So now we just need to factor out this part. So since the leading coefficient is 2 here, we have to multiply 2 times negative 15. So we need factor pairs of negative 30 that add up to 1. And factor pairs of negative 30 that add up to 1 are 6 and negative 5. We wouldn't use negative 6 and negative 5 because then our middle term would be a negative 1. So what we end up with then is x plus 6 and x minus 5. Since we multiplied by 2, we have to divide the constant in each expression by 2. And we get x plus 3, and then 5 divided by 2 is 2.5. We're going to leave it as an improper fraction. The 2 comes up here, and we get 2x minus 5. So to factor this completely, our final answer, we have to include that GCF that we factored out. I'm just going to erase this up here so I have room. So we're going to include the GCF that we factored out. We factored out the 2, and then when we factored completely down here, we had x plus 3, and then 2x minus 5. So factor completely 4x squared plus 2x minus 30 equals 2 times the quantity x plus 3 times the quantity 2x minus 5. Okay, in example number 2, it looks like we have the difference of 2 squares, and we do, so there's actually 2 ways to do this. Let me get rid of my little gnome guys right there. Okay, so we have to find the GCF of 16 and 64, and the GCF is 16. So we're going to factor out 16 on each of these terms, and we get 16 times x squared, because these guys cancel out, and then 64 divided by 16 is 4. So now we have the difference of 2 squares right here. So square root of x squared is x. The square root of 4 is 2. So we have x plus 2. And since it's the difference, then we have x minus 2. And that is equal to 16 x squared minus 64. Okay, so what if we factor out the GCF, or we can't factor out a GCF, but we have way too many terms. So let's take a look at factoring by grouping. So in this case, we have 4 terms. So if we look at example number 1, we have 3n cubed minus 12n squared plus 2n minus 8. So we want to group the two pairs of terms together. And usually it's the first 2 and the second 2. So I'm going to group them with parentheses. So I'm going to group 3n cubed minus 12n squared, and then 2n minus 8. So now I want to find a GCF for 3n cubed minus 12n squared, and that GCF is 3n. So I'm going to divide this term by 3n squared, and this term by 3n squared. And when I do that, I'm factoring out the 3n squared. 3n cubed divided by 3n squared is just equal to n, minus 12 divided by 3 is 4, and n squared divided by n squared is 1, so we have 3n squared times the quantity n minus 4. So when we're factoring our next set of parentheses, we want to make sure that n minus 4 ends up in the parentheses after I factor out the GCF, because otherwise it's not going to do us any good. So the GCF of 2n and 8 is 2. So I'm going to write the plus 2. 2n divided by 2 is n, which is what we have right here. And then 8 divided by 2 is 4, which is what we have right here. So we're not quite finished. So now we need to factor this. Both of our terms, the red and the blue in this case, have an n minus 4. So that is 1. The n minus 4 is going to be one of our factors. So we have n minus 4. When we take that away, what we're left with is our other factor, which is 3n squared plus 2. Could you write it as 3n squared plus 2 times n minus 4? Absolutely, but when we multiply those together, what we should end up with, and we do, is 3n cubed minus 12n squared plus 2n minus 8. So here is our first factor pair, 3n squared plus 2, which is right here, and our second factor pair, or our second factor, is n minus 4. Go ahead and try the last example and then check back for your answer. Okay, so let's take a look. I factored by grouping. My first pair of factors was 8t squared plus 14t, or 8t cubed plus 14t squared. I factored out a 2t squared because the GCF of 8 and 14 is t, and the GCF of t cubed and t squared is t squared. So 8t cubed divided by 2t squared gives me 4t. 14t squared divided by 2t squared gives me 7, and here is my GCF that I factored out. 20t plus 35, the GCF of 20 and 35 is 5. There's no variable GCF, so it's just plain old 5, so here's my 5. 20t divided by 5 is 4t, 35 divided by 5 is 7. So these two terms match, 4t plus 7, 4t plus 7. That is my first factor. Once I take out 4t plus 7, factor it out, I'm left with 2t squared plus 5. So the 8t cubed plus 14t squared plus 20t plus 35 completely factored is 4t plus 7 times 2t squared plus 5. Could you write it 2t squared plus 5 times the quantity 4t plus 7? Absolutely you could. Either way is fine. Okay, now it's your turn. Multiple choice question number 1. Factor completely the expression 2y squared plus 12y minus 54. First, ask yourself this question: is there a greatest common factor? If there is, factor that out first. And in number 2, you're going to factor by grouping. So group two terms together. So you have one set of parentheses with two terms, another set of parentheses with two terms, and then you're going to factor out the GCF for that pair of terms, or those pairs of terms. And then follow the directions like we did on the notes. If you have any questions, please put those in the Google form. Have a good night.